The other day we did VTI under the tunnel interface. We called the IPSEC for protection, so that any traffic that passed through will not only be encapsulated with the additional layer 3 header, the traffic will also be an encrypted one. The payload from layer 3 to 7 will be encrypted one. By using the upper layer of layer 3, the packets are routed, which is basically the tunnel identification layer. Now, we can also negotiate tunnel using another feature called crypto map. So this is also a site-to-site VPN, but we are not going to use that GRE or MGRE. This is using crypto map. So we can go straight. So in the previous class, we had this tunnel interface. But this time we are not going to have tunnel interface. We are going to use crypto map. So there won't be any need for tunnel interface or tunnel interface IP address. This is not needed. Okay, so going to router 1 to remove the tunnel. That is what I'm going to do. First job, remove the tunnel. No tunnel interface. We are going to use crypto map. The crypto map is a kind of tunnel that is going to be established between F00 of R1 and R2. We are not going to have an interface called tunnel 0. We are going to make use of the same physical interface F00 along with crypto map. So the first thing is remove the tunnel. No interface tunnel 0. I removed. Show IP interface brief. There is no tunnel interface at all. So on R2 also I'm going to remove the tunnel. No interface tunnel 0. Now I should be able to ping between R1 and R2. R1 and R2 reachability is given by ISP, isn't it? So we should be able to ping that. This is the address I am trying to ping from router 1. If ISP is providing route, I should be able to ping. In the real world, it is ISP's job In here, I think we are running OSPF to form adjacency between these transit routers and to have reachability between these customer edges. Without tunnel, this should ping. Okay, we need to troubleshoot. Go to router 4 and check whether you got two neighbors. Yes, I see neighbors. Show IP OSPF neighbor. What about router 3 and 1? Here also I see show IP OSPF neighbor. Yeah, then why I'm not able to ping? Let's try again. It's pinging now. It took some time for convergence. Ping is happening. Now, to protect the tunnel, we attached something. What is that? To protect the tunnel and tunnel traffic, we attached something to the tunnel. What is that? That's true, but IPSEC what? Profile. Okay. We attached IPSEC profile. We use the command tunnel protection IPSEC profile and then profile name we gave. Let me show you the profile. Show run section crypto. This will show all the crypto configurations. You see, this is the profile we attached under the tunnel interface. This is not needed. This is needed. This is needed. All these are needed. No change in all this. No change in all this. This I did not configure. It is default. And these two lines are not needed for crypto map. So I'm going to remove this one. Profile is not needed. Likewise on R2, I'll do that. To show. Surprise. No configuration. Show run. Unfortunately, there is no crypto configuration. It got erased. It's okay. We have to do it. I'll copy from R1 these things. I'll copy all these things except the IP address. IP address will change on R2. So the IP address is going to be 40001. And also I'm going to copy this transform set. Enough. So phase 1 and phase 2 configured. Now look at this. What we are going to do. We are going to write an access list. Access list 101 permit IP traffic going from the network 10.0.0.0 network to the network 172.16.0.0 network. Why I'm writing this access list? I'm going to tell the crypto map if this traffic is found going from 10 to 172, you need to encrypt. You need to use the tunnel. Likewise on R1, permit IP, traffic from 172.16.0.0 going to 10.0.0 should be encrypted, so I'm writing this. Now, crypto map 1, IPSEC crypto map 1, crypto map. Okay, I'll give the name first. CMAP, sequence number 1, IPSEC ISA KMP. Right? I'm saying this is IPSEC ISA KMP phase 1. This is going to have a phase 2 crypto map. Set transform set. What is the transform set name we gave? T-set. And then match address. What is the access list number? This is the address, the traffic address should match. And then, what is the other things? Set match. Transform set is, okay, peer. Who is the remote peer? For 20.0.0.2. So there are two set command. One is set transform set, another one is set peer. Another address is access list. These three are important. All others are not that important. Next, do show run. I'm going to copy the 3 lines of crypto map. This is it. What will change on the other router is the peer. So I'll just paste up to here. Peer is 40.0.1. And the other 2 lines are same. Set transform set and access list number. Am I right? Did I give 101? Access list number? Yeah, 101. Now we have to go to the physical interface. Interface that faces the WAN F00 IP crypto map CMAP. That's it. Enter. You see, phase 1 is on. Do the same on router 1. That is all. Now, we should write a static route now. Show run section IP route. Do I have a route, static route already? IP. No. So I'm going to say IP route. If you want to go to 10 network, just go out via F00. Listen carefully. Router 3 and router 4 has got no idea about 10 network. I'm just saying go out on this interface. Why I'm saying, when it tries to go out, crypto will take care. Crypto will do the encryption, encapsulation. It will put this 40 as a source, 20 as the destination, and it will set. So I'm just trying to kickstart by sending the traffic to that side where the crypto map is. Likewise, I'll go to router 2 and say IP route 172.16. Send the traffic to or F00. Or you can say like this 20.0.0. Some number. I really don't have 20.0.0.20. I just got only 20.0.0.4 and 2, I think. Just, for making the route to go out on the 20 interface, I'm putting some address. You can also see interface as I said in the other router. Okay. Now let us verify. You know very well router 3 has got no routes for 10 and 172. Router 4 also don't have route. But when you go to router 1 and try ping 10.0.0.1 with a source of 172.16.0.1. Initially it will kickstart and then it will come up. Let us check whether the tunnel has come up. Show crypto IPSEC AMPSA. Oh no, tunnel has not come. Tunnel has not come. Phase 1 itself is a problem. Why? Show run section crypto. I know why. On router 2, we copied and pasted a wrong thing. This is a wrong thing. No, it's correct. Is R140001? Yes, it is. Then where? Let me try pinging 10.0.0, sorry, 172. This side is good. What happened to the other side? Oh, this side is also good now. The ping should happen at any time. Let's go to router 2 while this is pinging. Let us say IPSEC SA to see whether any packet is getting. No, we see only the sending error. Okay, I think there is a problem with my static route. Show IP route. I'm going to change the static route. Let me say go via F00. Some operating system has got some issues like that, so I'm changing. I don't know whether the problem is. Tunnel is VPN phase 1 is good. I can see phase 1 is good, but only the phase 2. No error found here, but no packets are encrypted. The problem is maybe with my access list. Show IP access list. Any traffic going from 172.16. I forgot to put 10. You understand? You know how I found that mistake? I found it here. How can the remote identification be 0? Local is 172.16, but remote should be 10. That is how I check the access list. No. கரெக்ட் தானே நீங்களே முடிவு பண்ணி கேட்கக்கூடாது. டனல் வந்து கிரிப்டோ தான் கிரியேட் பண்ணுது. Loopback is like we are simulating an inside network. We are simulating some inside LAN network. Both. Okay, here are the access lists are correct. Now the ping will happen. Oh, 15 errors. So that is some error to be fixed. Here there is no error. The problem is on the other side. What? Still not changed. What is this? Show IP access list. What a surprise. No access list 101. Remote. Access list 101 permit IP. Any traffic coming from this network 172.16, which is my local network, going to 10.0. Show run interface F00. Do I have the crypto map? Yes, I do. Show run section. Okay. Section crypto map. Okay, CryptoMap is calling the access list. Perfect. Now let's try pinging. Okay, it is. Let's check whether the decryption happened in R2. Last time it was showing error. This time no error. Yeah, 4 packet got decrypted. Because the first packet was like ARP, taking some time. Let's ping again. I should see 9 packet. Instead of 4, I should see 9 now. Yes, 9 packets. So we can see the encryption decryption happens for the traffic that is going only between the LAN networks of these two sites. Right? This is how we use CryptoMap to encrypt. Okay, so we'll